Here's some help with challenge exercise 958 from problem set 3A. The question gives us two pieces of quantitative information and a conversion factor. It also gives us a balanced chemical equation, and it asks us to find two things: how much reactant was left over and the volume of gas that was produced. We're going to tackle it step by step. First, we'll determine how much sugar had to be decomposed to make 11.96 grams of C2H5OH. That's ethanol, by the way. This is the map of how we're going to solve the first part of the problem. We'll start with the grams of C2H5OH. We'll use the molar mass of C2H5OH to get moles of C2H5OH. From there, we can use a mole ratio to get to moles of glucose, C6H12O6. And then we'll use another molar mass to get to grams of C6H12O6. To get the molar mass of ethanol, we take 2 times the average atomic mass of carbon, plus 6 times the average atomic mass of hydrogen, plus 1 times the average atomic mass of oxygen, and we get 46.07 grams per mole. To get the molar mass of glucose, we take 6 times 12.011, which is the average atomic mass of carbon, plus 12 times 1.008 for the hydrogens, plus 6 times 16 for the oxygens. This gives us 180.16 grams per mole. Now we're ready to set up our calculation. Starting with the given 11.96 grams of ethanol, I first use the molar mass of ethanol to convert grams of C2H5OH to moles of C2H5OH, so grams cancels. I then use the mole ratio. Since at this point I have moles of C2H5OH in my numerator, moles of C2H5OH has to go in the denominator of my conversion factor, and the coefficient is 2. That's why I have 2 moles of C2H5OH here in my denominator. So moles of C2H5OH cancels, and now I have moles of C6H12O6. And I can use the molar mass of C6H12O6 to cancel moles of C6H12O6. Plugging this all into my calculator, I get that we consumed 23.39 grams of C6H12O6. The question states that we started out with 24.48 grams of C6H12O6. So how much is left over? We just subtract the amount we used from the amount we started with. In other words, 24.48 grams minus 23.39 grams. Punching that into my calculator, the difference is 1.09 grams. That's how much excess sugar we had. There's that much unreacted sugar left over when the reaction stops. The next part of the question is to determine what volume of gas is produced. Recall that our chemical reaction is the decomposition of the sugar glucose, C6H12O6, to make 2 moles of ethanol, C2H5OH, and 2 moles of CO2. The CO2 is our gas. So we're going to do a stoichiometry calculation where we'll start with the grams of C2H5OH produced. That's our given. We'll use the molar mass to get to moles of C2H5OH. Then we'll use a mole ratio to get to moles of CO2. And finally, we'll use the ideal gas equation to get to liters of CO2. So I've got 11.96 grams of C2H5OH, that was my given. I divide by 46.07 grams per mole. Grams of C2H5OH cancels. I now use the mole ratio. I produce 2 moles of CO2 for every 2 moles of C2H5OH. So moles of C2H5OH cancels, and now I have moles of CO2. And the calculator says 0.2596. Now we can use the ideal gas equation to figure out the volume. So the first thing we'll do is we'll divide both sides by V, and we get P equals nRT over V. Now, we know N, we just figured it out. R is the universal gas constant, whose value is 0.8206 liters times atmospheres over Kelvin times moles, Latin per camel. Then if we assume that our temperature is the freezing temperature of water, 273 kelvins, and our pressure is 1 atmosphere, that's standard temperature and pressure, abbreviated STP, we are ready to plug in our numbers. Plugging in the numbers, V equals 0.2596 moles times R, 0.08206 liters times atmospheres over Kelvin times moles, times T, 298 kelvins. I'm sorry, 273 kelvins. Over P, 1.00 atmospheres. And punching that into the calculator, we get 5.816 liters. It's worth mentioning that at standard temperature and pressure, 1 mole of gas has a volume of 22.41 liters. This is called the standard molar volume. You can use this as a conversion factor. If we take our number of moles of gas, 0.2596 moles, and we multiply it by 22.41 liters in 1 mole, moles cancel, and we get an answer that's very similar to what we had before, 5.817 liters.